Various studies report that nearly 9 out of 10 spreadsheets contain errors, with the majority the result of human error relating to formulas. These errors have cost companies millions, and they can put your reputation and career on the line. In this video, I'll guide you through a simple yet powerful formula checklist to help you avoid costly, embarrassing mistakes that could derail your professional progress. And stick around to the end. I've got a free tool for you that will help you catch errors before they catch up to you. All right. Let's kick things off with a quick visual scan. This is your first line of defense against formula errors, and it's super easy. Thankfully, formula error messages like the hash value here stand out like a sore thumb. But if you have large spreadsheets with a lot of data, there are a few ways you can quickly locate errors. First, on the Formulas tab, we've got error checking. This brings up a dialog box, and you can see the first error value is selected. And here I can get help on this error, show the calculation steps, ignore it, or edit it in the formula bar, and then I can navigate to the previous or next error. And there we found another one towards the bottom. Now another way you can locate all the errors in your worksheet is using the Find tool. The keyboard shortcut is Control F. This brings up the dialog box. So what am I finding? Well, all Excel errors begin with the hash, and then in order to find all of them, I'm going to use the wildcard asterisk character. Where am I finding them within? I can either look just at the sheet or the whole workbook, and I want to look in values and then find all. And this gives me a list of all the errors in my workbook. You can see the workbook name, the sheet it's on, the cell that contains the error itself, and then the formula. And I can use this to navigate through them. So I can click on this, it's a hyperlink, takes me to the cell containing the error. I can click in the worksheet, correct the error, and then move on to the next one, and so on. The next common error is a circular reference. Now Excel should give you a warning when you open the file that there are circular references, but many people don't know how to actually find them. Excel will also tell you in the bottom left of the window that the file contains circular references. And there are two ways to find the cell containing the circular reference. First, simply go to each sheet until the cell reference beside circular references appears. So here we can see cell B11 contains a circular reference. And if we look in the formula bar, you can see this cell is simply referencing itself. I can delete that, and now it's giving me the next circular reference is in cell B4, and I can select that and correct it. But another way we can locate circular references is again on the Formulas tab. Click on the error checking drop down and then circular references. It's telling me the next one is on the sheet called circular ref, cell C13. Click on it and it takes you there. So I can correct this. This should only go to C12. And then you can see at the bottom, all my circular references are cleared up because the message is no longer there. Excel also uses error indicators on cells. These are the green flags in the top left of the cells that contain errors, but they also appear on cells that contain inconsistencies, like we have here with these formulas. Now, when you insert a formula in an Excel table, Excel expects the formula in each row of a column to be the same. If you look in the formula bar as I arrow down through the cells, you can see some contain formulas, others contain hard-keyed values, so they're inconsistent, which is why we've got these green error indicators. Now you can click on the warning drop-down and it tells me there's an inconsistent calculated column formula. And I can restore to calculated column formula, and that's going to copy the formula down the whole column if there's only one formula. But in this case, I've got multiple, so it's not going to know what to do, so it'll do nothing. I can get help with the error. I can ignore it. In this case, I actually want my formulas to be different down the column because I'm looking at my data across each row. So I actually want to ignore the errors. Alternatively, I could edit it in the formula bar, or I can open the error checking options. If we look at error checking options, you can see here I can turn off the error checking. I can change the color of the flag, or I can reset ignored errors. Let's cancel that because I want to select all the cells in the table, and then I'm going to ignore all errors in one go. The next step is checking your input. Here I've got a formula that references other cells. To double check the references, we can go to the Formulas tab and then Trace Precedence. And we can see the cells that are being referenced, which look correct. Obviously,
If there was a cell reference that was on another sheet or workbook that you weren't expecting, this might immediately indicate something's wrong. Now, if the cells are out of sight, you can double-click on these blue arrows and it jumps you to the cell. Double-click again and it takes you back to the formula cell. Now, I'll just turn the arrows off because another way we can check inputs is with the F2 key to go into edit mode. This color codes the cells with the formula arguments so you can check that the correct cells are being referenced. Another thing to watch out for are hidden cells. Sometimes we hide rows or columns to make spreadsheets more manageable, but then we forget they might contain data that affects our formulas. To unhide everything, select the whole sheet and then right-click on the rows and unhide. And then do the same for the columns. Just make sure everything is unhidden. And now we can see we've got a total at the bottom and at the top, but they're different. If we F2 to edit the total at the top, you can see it includes the total at the bottom. It's obviously extended past the bottom of the table to allow that table to grow, but we forgot we've got a total down here in a hidden row. So let's delete that, and now our total at the top is correct.
Now it's time to put on our thinking caps and do a logic check. This is where we make sure our formula is actually doing what we expect. First, step back and ask yourself, does this formula make sense for what I'm trying to do?
Here I'm calculating the average sales, but notice there are 0 sales for tights. So while the average formula is correct, I'm not sure I should include 0 sales for tights in the calculation because this will be reducing the average. If I delete 0 for tights, notice the average at the bottom increases, which is more likely what I want. In this table, I'm forecasting the sales for an upcoming period, and it's just a crude forecast that assumes sales will increase by 5%. Now I can do a quick check that my total forecast is correct by adding 5% to my total sales. And now we can see the forecast appears correct.
Another strategy you can use is to break overly complex nested formulas out into separate formulas. This will help you test and debug them more easily. And the bonus is it's often more efficient for Excel to calculate many separate formulas than one big convoluted one. Okay, now that we've checked our formulas for logic, you might be thinking, well, this is great, but what if I want to take my formula skills to the next level? Well, that's where my Advanced Excel Formulas course comes in. Mastering Excel formulas on your own can take years of trial and error. Whether you're picking up tips from colleagues or scouring the web, it's a slow process with inconsistent results. But I've designed this course to get you up to speed fast, focusing on the formulas that will save you time and effort. In just 5.5 hours, you'll learn everything from essential lookup functions like XLOOKUP to advanced functions like dynamic arrays and lambdas. Plus, I'll walk you through real-world examples and show you some less obvious tricks that'll truly set you apart in your work. If you're serious about becoming an Excel Formula Pro, check out the course. There's a link in the description below and pinned comment for you to explore more. Okay, we're on a roll. Now it's time for the range check. This is where we make sure our formulas are looking at the right cells. Start by checking absolute and relative cell references. Are you using an absolute reference like $A, $1, when you should be using a relative reference like A1 or vice versa?
Here I've got an XLOOKUP formula, and on the face of it, it looks correct, except for the last row, which is missing the category, and that looks a bit odd. If we look in the formula bar, you can see that I'm using the if not found argument to return a blank if it can't find the product in my lookup table, and therefore no errors being returned here. And this could also happen if you use error handling functions like ifNA or ifError. Now on closer inspection, if I edit the formula, you can see I don't have absolute references for my lookup array and return array. So when I copied my formula down, you can see the lookup array and return array shift down by 1 until we get to the point where the mountain bikes are outside the lookup array. And that's what's causing the problem. So let's select the cell references here and F4 to absolute, and then I'll copy this down, right click and drag and fill without formatting. And now we have the correct category returned for mountain bikes, and you can see the range is being referenced correctly. Here I have a formula that references a whole column. These are particularly dangerous if your users have a tendency to use Excel as a scratch pad or calculator. If we go to the very bottom, you can see there's a random calculation in a cell below the table, and that is being included in my sum formula at the top. So let's delete that. We'll go back to the top, and now my total is correctly only including my cost of goods sold. But this is one of the reasons I don't like whole column references. Another common problem I see is when rogue data is affecting a dynamic named range formula. For example, here I have a formula that sums the sales. You can see it's using a dynamic named range called sales. So as I add more data to the bottom, let's just add in another 1,000. You're going to see the sum formula automatically updates to include that value. And if we open the name manager, you can see here's my dynamic named range, and it uses the count A function to count the number of sales in column D. And it extends past the bottom of the table to allow me to add more values. But this is dangerous because people could enter data in this column. Now if I click in the refers to here, you can see the marching ants around the cells that are being returned in the range. So right now it's correct. Let's close that. But if I add some data in here, let's just add 2 values. It could be text or numbers, it doesn't matter. If we go back to the name manager and click in the refers to, you can see these 2 values have extended my range by 2, and now my sum formula is including the first 10 and therefore the wrong result. So be very careful of dynamic named ranges. They're pretty easy to check. Just open the name manager, click in the refers to, and we get the marching ants. And of course, if your formulas just use regular range references, press F2, we get the range highlighted, we can adjust it as required, and press enter.
Now the final step in our checklist is all about putting your formula through its paces with some simple calculation tests.
Here I've got a table containing gross sales, and I've added formulas to extract the tax and the net sales. To test the formulas calculating correctly, I can enter an amount that makes it easy to do the calculation in my head to validate it. For example, if my gross sales are 110, my tax should be 10, and the net sales 100. Let's enter it. Excel copies the formula down for me, and we can see the tax is 10, and therefore my net sales is 100, so I'm good to go. When you write complex formulas, it's a good idea to test edge cases. Try 0 and negative numbers and see what happens. For example, if we enter 0 in here, we now get a div error. If I delete the value for tights, I also get a div error. Now these errors might be acceptable, in which case you can wrap your formula in the if error function. And if it's an error, let's return 0, close parentheses, and then you can copy it down. Alternatively, you might need to edit your formula to accommodate blanks or zeros or large values or negatives, and that's why it's a good idea to test these edge cases.
Now remember the free tool I promised you at the start? Well, I've prepared a handy PDF with the full checklist that we just went through, and you can download it from the link in the video description or pinned comment. And if you've ever been confused about what all those Excel errors actually mean, I've got another freebie for you. I've created a cheat sheet that breaks down what causes each error, so you'll never be left guessing again. You can also grab that from the link in the description and pinned comment. And if you want to dive deeper into Excel formulas that will help you stand out, not only for the rest of 2024, but also into 2025 and beyond, check out this video next. I'll see you there.